Okay, hello everyone, my name is Delilah and we're going to be doing number 4 on the worksheet. The problem is y dx plus x ln of x minus ln of y minus 1 times dy equals 0. Okay, so because this is in the form m dx plus n dy equals 0, my immediate thought is, okay, it's either exact or homogeneous, hopefully. So I tried exact and it's not, so I'm going to save some time and just go straight to homogeneous. So in order to solve a homogeneous equation, what we want to do is check if it's homogeneous, which I already did, and I'm going to save some time by not doing that. So now that we know that it's homogeneous, we're going to substitute either y is equal to ux or x is equal to uy. So I have a strategy that I use where I want to make, so if we use y is equal to ux, then we also have to use dy is equal to u dx plus dux, right? And similar for x is equal to uy. And so you would have to multiply this out. And if you make it this one, like here, you have to multiply it out by all of these terms and it's really ugly. So I'm going to go ahead and make it, I'm going to use the one that has dx in it so I don't have to multiply it out by much. So then I would have dx is equal to duy plus udy. Okay, so now I'm just going to start plugging these two into my equation. So ux dx plus, oops, sorry. Okay. So this is y. So y stays y because we're using this one. In fact, I'm just going to erase this one. Y. And then we have our equation for dx. So duy plus y u dy plus uy ln of uy minus ln of y minus 1 dy equals 0. Okay, that's long and super horrible, but let's see if we can simplify it a little bit. We can use properties of lots to make this a little nicer. So ln of a minus ln of b is equal to ln of a over b. So using this, we can say that ln of uy minus ln of y is equal to ln of uy over y, and the y's cancel. So it's just going to be ln of u. And I'm going to erase this just so we can have a little bit more room. So I'm going to change this to uy ln of u, like we discussed before, minus 1 dy equals 0. And then I'm going to distribute this y out. So I'll have y squared du plus yu dy. Okay? And so we can notice something really neat here is that there is a y in every single one of our terms, and we're actually going to slash that y out. So here I'll just erase the 2 exponent, here I'll take this y out, here I'll take this y out, and then everything is fine. We're just dividing by y, and 0 divided by y is 0. So now we have y du plus u dy plus u ln of u minus, oh sorry, I forgot my dy. Dy, because we have to distribute to both, minus u dy equals 0. And so now we have something really neat here. We can cross out our u dy's. And so we have y du plus u ln u dy equals 0. And we want to put them on either side. So I'm just going to equals negative. And then in order to make sure that each of these variables only has their own variables in the integral, I'm just going to do a little bit of algebra and say that if we divide by this y and we divide by this negative u ln of u, we can have 1 over, so 1 times du over negative u ln of u is equal to 1 over y dy. And then we can integrate. And in order to integrate this, we can use a substitution. We can say that v is equal to ln of u. So dv is equal to 1 over u du, which we have a 1 over u du. So we can say the integral of 1 over v dv is equal to the integral of 1 over y dy. So we have negative ln of v, which is ln u, so we're just going to substitute that in now, plus c is equal to ln of y dy. Yeah, okay. So we're going to go ahead and solve. So this is our equation. So now we're just going to go ahead and solve for the IVP over here. So our IVP was y of 1 is equal to e. Oh shoot, sorry. This u, actually from the beginning, we know that u is equal to x over y. So we want to put that in before we do IVP. So now we have negative ln of x over y, so 1 over e, and 1 over e is actually e to the negative 1, and using log properties we're going to move the negative 1 out to the front and make this positive. We know that ln of e is equal to 1, and we know that ln of 1 is equal to 0. Oh, and also this is equal to ln of y, right? Where am I? Oh no, I lost my plus c. I'm sorry. Plus c. So ln of e is equal to 0, and ln of e is equal to 1, and ln of 1 is equal to 0. 0 plus c is equal to the natural log of y, which is e, which is equal to 1. Did I do something wrong? Because last time when I did it, okay, you know what, we're just going to go with it. So we get that c is equal to 1. Great. So now we want to plug back in here. So we have that negative natural log of x over y, that's ugly, plus 1 is equal to natural log of y. And then you can do e to the, and you can get that y is equal to, these cancel, and you can move the negative exponent up here. Ln of x over y to the negative 1. And then this is plus 1. And this is your final answer. Just say it, Nate.
Oh, when you raise it to the exponent, right, it turns into multiplication, right? So you have e, right? Don't you have, when you have, this part is not inside the natural log, so it doesn't cancel with the e.
This part isn't in there?
No, look at the parentheses. They end before the 1. The reason you got e the last time is that this becomes e to the blah 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 times e to the first.
Uh-huh.
And then e to the first is e. And that's why when you did it the first time, you got your constant as e.
Uh-huh.
So your constant will turn into E by the end of it.
I see.
Also, the negative 1 power goes outside the parentheses of the natural log, not
Thank you.
inside.
Cool. Okay, so negative
We can
1.
edit this, so it's continuous.
So,
And it becomes times E, right? Because...
Yeah.
Okay.
Because we can cancel this one out, but there's no ln here to cancel that one out. So then we can bring this to the front, and so then it would be E times ln of, right? Cool. This is my final answer. I hope you had fun.